Hi all. So I sent you an email today, means July 29th, at 12 itself, to join the class. What happened was that I think the mail went to your spam folder. That's the reason why nobody got the mail, I think. I was also wondering why nobody joined. Then I realized that a copy sent to my own email went to the spam, and I had to mark it not spam to get in the inbox. I think that's the reason why most of you did not join the class. So today I will record the class and I'll upload it, which you will watch. So next time please mark my email as not spam. I will give you the email in the group. So we talked about a few problems in tutorial. We solved problem number 1 and 2. Now 3 and 4 you have to solve it yourself, but I can give you some hints which will help you solve the problem. Question number 3 is that determine the maximum weight W the man can lift with constant velocity using the pulley system without and then with the leading block or pulley at A. The man has a weight 62 kilogram and the coefficient of static friction between the feet and the ground is 0.6. This is not very difficult. You have a man pulling a rope which is connected to a system of pulleys, and a weight W is hanging on it. So he wants to pull the weight and he wants to lift it with a constant velocity. So you don't need to worry about any acceleration of the system. Now there are two cases. First case, he is directly pulling the rope that comes from B, and in the second case he is using a extra pulley which we call a leading block here. So the question here is to determine the maximum weight W the man can lift without maximum weight man can lift. Now think about it intuitively, in which case will the man be able to lift higher weight? So what is the limiting case here? We don't need to worry about how strong the man is. That's not the aspect we are looking on. We have to we will have to assume that friction is the friction from the surface. Friction offered from the surface is the factor that is going to limit how much weight he can lift. So I'll give you a few hints. I will not fully solve the problem, but will give you a few hints. Here the pulleys are frictionless, which means the rope will have the same tension everywhere. Same rope will have the same tension everywhere. So this from here to here, it's a continuous rope. But after that, you can see that there is another rope which connects pulley C to the weight W, and there is another rope which connect B to the small pulley. So there are three different ropes here. One is the long rope, and this short rope, and this short rope. So in the same rope, the tension should be the same. So if you take the block C, you have weight W hanging, a piece of rope here, and a rope here. They will all have tensions, and we can call the tension in the rope here T1. This is nothing but W. Weight will be the tension offered by this rope, and here you have another rope. I think you don't need to worry about it. Okay. You can solve the problem yourself. I'm not going to fully solve the problem. So here in this case, you can see that here you have T1, here also T1, here also T1. Why? Because it's the same rope. This rope is starting from here and ending here without any discontinuity. After that, you have a different rope. So 3T1 is equal to W, means T1 is equal to, or I will not write anything else. This is the relation. 3T1 is equal to W. So you will get that relation, and when it comes to the man, in the first case, this is the man. So we don't need to worry about his shape or anything. We'll just so we have tension T1. We will now draw the different external forces on the man. So we have the tension T1 acting in this direction, which is 45 degree here. Weight of the man, I think weight of the man is something like 62 kilograms. So 62 G will be the weight. If I remember correctly, I'm not really sure. So what other forces do we have? Obviously friction. So what will be the value of friction? That will be equal to the normal force from the surface. So that will also be an external force on the man, right? There will be weight downwards, and there will be normal force from the surface on the man. And there is tension, there is friction, and the value of friction is equal to mu n, where mu is given. Now for this is for this guy, and in this case what happens? You have the man here, and just like the previous case, you have weight and normal force, which is 62 G and N here. Now this T1 is acting horizontally, and mu n here. You can actually, if you think about it, you can see that the weight of the man Here the full weight of the man comes as a normal force, because of which he will get higher value of friction, mu n, because of which probably he will be able to lift more weight. In this case, the weight of the man is being distributed into normal component and part of the tension, because of which maybe friction offered by the surface will be lower. You can calculate it. I will not talk about it. You can solve the system. So that's it. Now second problem. This is the second problem. The block brake is used to stop the wheel from rotating when the wheel is subjected to a couple moment m. If the coefficient of static friction between the wheel and the block is mu, determine the smallest force P that should be applied. So this is like a brake. You have a wheel which is rotating, and you're using this frictional surfaces in contact to stop the wheel. You are applying a force P here. This is like a braking system we usually have in, we usually have a complex braking system in vehicles, but much simpler one in some simple cycles. So essentially the same principle. You apply a force somewhere, and because of which you force a surface with a rough surface onto the wheel, because of which the wheel comes to a stop. Now the moment on the wheel is m, the torque on the wheel is m, which may be offered by an engine or something. So we have to make sure that the wheel does not move. What is the minimum force P required to stop the wheel? This is again not difficult. I don't think I can solve I don't have really time to solve all of these problems, so you have to solve it yourself. So I'll just tell you how you do that. So this is our question. So the wheel has a moment m from an external source here. So if you consider the wheel it's an external torque m, the wheel has a radius r. So now with what force can we stop it? So let's first draw the all external forces on the wheel. So the wheel, the point where the wheel is connected to the fixed surface, that will offer some normal force. Not necessarily normal, a force in some direction, right? Force in some direction, not necessarily normal, but I don't think we have to worry about it. Okay, in a force in arbitrary direction, that's okay. And now there is a normal force from the surface of the bar to the surface of the wheel, and there is also frictional force on the wheel. What will be the direction of frictional force? If this is trying to rotate in this direction, if you want to stop it, the friction should be in opposite direction, so that will be mu n. where N and here is the normal force. Now the torque, the mu n should provide large enough force to counter the torque. So the torque M should be equal to calculate the minimum, we want to calculate the minimum force, hence the torque is equal to mu n multiplied by R. Now when it comes to the bar is fixed, not fixed, pin joint here, and you have force P applied here, and normal force from the wheel on the bar, and friction from the wheel on the bar. Right. Friction from the bar on the wheel in this direction, so friction from the wheel on the bar will be in this direction. The normal force from the bar on the wheel is in this direction, and normal force from the wheel on the bar will be in this direction. So that's okay. Now this distance is, this whole distance is A, and this small distance is B. Now you know what to do. You take moment about C. If you take moment about C, again of course there will be a support force in some arbitrary direction, we don't know, but that doesn't matter because we will take moment about C. So the perpendicular distance between line of action of the support force and the point about which we take moment will be 0. That will be cancelled out, and mu n is also passing through C, so that will also cancel out. So we will get taking moment about C, P multiplied by A in counterclockwise direction. We'll take it positive, and N multiplied by B, which is in clockwise direction, so we'll take it as negative. Sum should be 0. So this is the relationship between P and N, right? A and B are probably given values. I think it should be given, otherwise how will you calculate P? So P, relation between P and N is given, and relationship between N and M from here. So that's very easy for you to calculate the minimum force required to stop the wheel. Now that should be submitted as an assignment. I'll talk about it later, since this class is not live, and because of some miscommunication you could not join the class, but that's okay. Now I'll talk about one more problem in the friction, and we'll conclude this section, and we have to start the next section. So here we will talk about wedges. Wedges, there is nothing new here. This is the friction, the idea of friction we talked about in the previous classes. This is simply the continuation of the idea. It's absolutely nothing new here. You have a big block here. Coefficient of static friction between all surfaces of contact is 0.1. So the surface between B, the block, and the vertical wall, the wedge and the lower surface, and between the wedge and the block. The coefficient of static friction between all the surface of contact is 0.1. Now you have to determine the force P that must be applied to the wedge in order to lift the block having a weight 1000 Newton. Let's see how we do that. So the block has a weight 1000 Newton. it is set so. Yeah, so what was the final question? I forgot. So you have to determine the force P that must be applied to the wedge in order to lift the block. So you need to lift the block. Lift means you have to move it upward. So you must overcome the friction from the vertical surface. There will be a minimum force P for the wedge to stand there, or there, if the friction value is high enough, there may not be a minimum value, but so you have to understand the question. The question here is the force P that must be applied to the wedge in order to lift the block. So if the block B is to be lifted, it should move upwards. Should it move upwards, it should overcome the friction offered by the vertical surface. So that's the point you need to remember. So our strategy is same. We always draw the free body diagrams of the systems. Okay, so they are not talking about the weight of the wedge, so we don't need to consider it. So what are the different external forces on the block B? There is weight directly downwards, which is 1000 Newton, and there will be a normal force from the surface from the vertical surface, which we will call N1. This is 1000 Newton. Okay, get confusing. 1000 Newton. Now there will be a friction. What will be the direction of friction? It must be downwards, because if you are lifting the block B upwards, you have to overcome the friction which is downwards. So the friction will be, what is the value of friction? Value of friction is 0.1. Okay, 0.1. So 0.1 multiplied by N will be the friction. And what other forces do you have? You will have normal force here. And what will be the direction of that normal force? The direction, this angle here is alpha. So the contact happened between this surface and this surface. So the normal force by the block on the wedge and by the wedge on the block will be the same. So the surface we need to consider here is this surface. So there will be a normal force perpendicular to this surface. So that gives you, so that is perpendicular to this surface. Now these two will be parallel and this is alpha. So that gives you the direction of the N2, which means this is alpha and this is 90 minus alpha. What is the value of alpha? Value of alpha is not given. think value of alpha should be given, otherwise okay, you can or you can write the output value in terms of alpha. That will be fine. Yeah, so normal force here and friction here also. So this is being lifted upwards. If this is being lifted upwards, this wedge will go inside. So it will try to push it in this direction, right? So the friction should be (0.1 into N2). So this is N1 and this is N2. Wedge will go inside towards left, and wedge will try to carry the block along with it. So the friction will be in this direction. But the block will offers resistance in the opposite direction, 0.1 N2, which would be the same. Normal force, again normal force from the block on the wedge will be N2, and you have external force P. And when the wedge is trying to move inwards, the surface will try to prevent it. Whose value will be proportional to the normal force. The normal force from the surface on the wedge will be N3, and 0.1 N3 will be the friction. So that's that's it. Now you can see that we have a problem here. Now how do we solve this? So here you have unknowns N1 and N2. Here you have N2, N3 and P. It's the total number of unknowns in the combined system. So you will get two equations from here. Two equations. Which are the two equations? Sigma fx is equal to 0, sigma fy is equal to 0. And you will get two equations from here. Which are those? Sigma fx is equal to 0, sigma fy is equal to 0. So you will get total 4 equations. And how many unknowns? N1 is an unknown, N2 is an unknown, N3 is an unknown, P is an unknown. So 4 unknowns. 4 equations and 4 unknowns. You can solve the system. And you can solve the system and calculate the P required. Now you will ask, what about alpha? Alpha is an unknown here, but we will take it as an input parameter. Take it as an input parameter and calculate P. And you will see that this is something you have to do, right? And you will see how changing alpha will help or prevent us from lifting the block. So if you would like to make a wedge, if you would like to design a wedge with a certain angle, should the angle be small or large, so that we will be able to lift the block P upwards easily? How much help do we get from the value of alpha being small or being large. So this is something you can figure out if you solve this problem. So this is not difficult, right? Here so all these angles you already know. This is alpha, right? So sigma fx is equal to 0 means here n1 will be equal to, so should I write it down? I don't think so. You can do it yourself. I have done almost everything else. Have I forgotten something? Okay, if there is any mistake, you do let me know. Okay, I think I will stop here since this is not a live class. Maybe I should not cover a lot of portions. Here I will stop. So solve all of these problems. And I will announce tutorial sheet 2 as an assignment later. Today we'll stop.